So just wait for another 2-3 minutes. At 12:03 only we'll start.
Okay.
Students are joining. Minimum 20-25 students join. Then we start. So good afternoon, all present here, all the participants. So today we have with us Dr. Azamimi Abdullah from Malaysia. Um, uh, Actually, let me introduce Dr. Aziana. She is an associate professor in the Faculty of Electronics Engineering and Technology at University Malaysia, Perlis, Malaysia. She earned her PhD from Graduate School of Information Science at Nara Institute of Science and Technology, Japan, and completed her bachelor and master in electrical and electronics engineering at the University of Tokushima, Japan. Prior to her academic career, she worked as an engineer at Toshiba Electronics. Her research interests include bioinformatics, AI, machine learning, big data, data mining, and computational intelligence. Dr. Abdullah has published extensively, presenting her work at international journals and conferences, and serves as a reviewer for academic journals. And Dr. Aziana has working with me for the last 3 to 4 years. So hopefully this year also we are going to prepare a new roadmap how we can collaborate in biomedical email processing. We'll see. Now, thank you very much, ma'am. Now session is yours. You can share and start the session. Thank
Okay, let me share. Can you see the slide?
you. Yes, ma'am.
Okay. Okay. Good evening, everyone. In Malaysia time, now is 2:30 p.m. But maybe in India is still morning. Okay. First of all, I would like to say thank you to Professor Satya Ranjadash for inviting me for this winter school. Okay. So I think this is my second time delivering this kind of talk to the students of KIIT, right?
Yes.
Yeah, I'm very honored to accept this invitation to deliver my project, my knowledge in biomedical image processing and also artificial intelligence. Okay, need to hide this one. Yeah. This one. Can you see my slide?
Yes, ma'am.
Okay.
Deep learning based classification of degenerative spine condition from lumbar MRI.
Okay. Okay, so for today's talk, I would like to present my research project. This is actually my student final year project. The title is the Deep Learning Based Classification of Degenerative Spine Condition from Lumbar MRI. Okay, wait, yeah. Okay. So, my name is Azian Abdullah. Currently, I'm an associate professor at Universiti Malaysia Perlis, in Malaysia. So, for today's talk, I will explain first about the degenerative spine, the low back pain condition, and how we use the deep learning technique to diagnose the spine condition. Okay. So at the end of this talk, maybe I will show some of the data set, some of the coding for you to try later on. Okay. So this is the contents of today's presentation. First, I will do introduction, and then literature review, methodology, results and discussion, and also conclusion. Okay, so before I start, I want to ask whether how many of you experienced the low back pain before? Any of you? One student raise your hand, so that means you are quite familiar with the low back pain. Okay, so low back pain is not only a medical issue, but it's actually a global health issue where most of us can get this low back pain disease. So even in Malaysia, there are a lot of patient, okay, experience the low back pain. Okay, so uh, until now, okay, it is about 690 million cases, okay, in 2020, and it's about 60% of increase since 1990. So the age normally the older the patient, the older the higher probability we get the low back pain. So for age 18 to 44, there are 24.4% of the cases. Okay, and for the adult, like 45 to 64 years old, there are 33% of cases. And then for the age 75 and over, say over 75, it is a higher percentage, around 37.3% of cases. So most of the patient of the low back pain is from the elderly man or woman. And the studies show that low back pain affect women more often than men. Okay, it is because maybe especially for the menopause woman, it is due to the hormone changes. So more women affected low back pain compared to men. Okay, and then for the global back pain crisis, overall there are 619 million people affected. Okay, the worldwide cases of low back pain in 2020, and it is estimated that 843 million, okay, will be expected to have low back pain. Okay, so this quite worrying because the low back pain will affect the disability, discomfort, and many more issues. And even in Malaysia, 84.6% is the prevalence. Okay, so the rates vary from 12 to 4% to 84.6% across the group. Okay, so the problem, okay, occurred by this low back pain. Okay, as you may know, low back pain is actually the pain or discomfort uh, at the located in the lumbar region, on the spine, which is the lower part of the back. So means at the back of your body, okay, from the up until buttocks. So this is the low back pain area. So the problem current problem face is the manual diagnosis limitation. So then diagnosing degenerative spine condition with MRI is prone to subjectivity, leading to error, variability, and treatment delays. So most of cases, we only depend on the radiologists or doctors, which manual interpretation. That means it is based on the human meta expert. So it is not automated, it's a manual. So maybe it can be lead to misdiagnosis or some of error. So, and of course, it will lead to miss early detection. So early degenerative changes are often missed, delaying treatment and worsening outcomes. So if the low back pain detect late, okay, so it will delay the treatment, okay, the treatment, and also will delay uh, uh, the treatment and also the surgery and all that. Okay, so early detection is very important to overcome this problem. And data complexity. So one of the diagnosis method are MRI, the medical imaging, but the large MRI dataset will slow down the diagnosis and increase error from radiologist fatigue. So the objective of this project, first, to implement data visualization techniques and exploratory data analysis EDA on the lumbar spine data for better understanding of the medical condition. First, we try to implement the exploratory data analysis technique first, okay, to understand more about the data. And the second is to implement the deep learning models, okay, to detect and classify the degenerative spine condition using the lumbar spine MRI data. And the third objective is to develop a graphical user interface UI to help the users to diagnose the degenerative spine condition automatically. Okay, so this is our project objective. And the scope of this project, okay, because of the limitation of the data, so we use the open source data set, okay, the online data set, which is the RSNA data set. So this data set obtained from this radiology society, okay, from the USA, and it is available online, okay, and you can also try to use the data, the image. So, and then implement your deep learning or AI technique to diagnose. So, I will show you later the data set, and then you can explore more about the data. Okay. And then the data set will be explored and visualized to overview the data. So this is the exploratory data analysis and data visualization technique. And that next is the image pre-processing. Before we can implement the deep learning or AI, we need to pre-process the image first. So the dataset will undergo the pre-processing. And then after that, we will do the deep learning, implement the deep learning algorithm. We need to determine which deep learning model are suitable for detection and classification of the degenerative spine. So there are a lot of algorithms out there. So for this project, we implement just two to compare. So if you have time, maybe you can explore other algorithms and try to implement using the dataset. And then finally, because we want to have a user-friendly interface, okay, the user can upload the image and then the result or the diagnosis result will come out. Okay, so we implement the GUI, okay, to make an interaction between users and the system to make it user-friendly. So for the literature review, okay, so first I will explain what is the degenerative spine. Okay, so as you can see in this figure, oops. Okay, so these are the low back. Okay, start with the cervical spine. So, and this is the thoracic spine. Lumbar spine is the bottom one. and then the sacral spine and the coccygeal spine. So there are five categories. So the spine is a series of connected bones extending from the skull, okay, from this to the pelvis, supporting the body, protecting the spinal cord, and allowing movement. Okay, so the degenerative spine refers to the gradual wear and tear of the spinal structures, such as disc, joint, and vertebrae, leading to pain and reduced mobility. So the aging is the main factor, okay, one of the main factor to get this degenerative spine. So um, it will give some discomfort, okay, discomfort and leading to pain. Okay, so for the diagnosis method, okay, for the degenerative spine condition, medical imaging use, okay, so there are many techniques of medical imaging such as the MRI, the computed tomography, and X-ray technique. And the most common, the most effective one is the MRI modalities because the image are very clear and sharp. Okay, so in order to diagnose the degenerative spine, so we use three plane. Okay, for the MRI, there are sagittal plane, okay, coronal plane, and axial plane. Okay, for the MRI modalities for this degenerative spine, okay, for the axial T2, this one is used to detect the subarticular stenosis. So it is one of the condition of the spine. Okay, so this axial T2, okay, will detect the subarticular stenosis. The sagittal T1, this, the sagittal, will detect the neuroforaminal narrowing, and sagittal T2 and STR detects spinal canal stenosis. So this is the MRI modality. So every modality can detect different condition of degenerative spine. Okay, so before we move to the methodology, first I will explain about the related research work, okay, that we can refer and compare, okay, their method and with our method. So the first journal is a deep learning model for detection of cervical spine cord compression of MRI scan. So the data used for this study, they used 289 patient MRI scan, including 6,588 images for training and 2,991 for testing, focus on spinal cord only. Okay, but they do not focus on this subarticular stenosis and neuroforaminal narrowing. So they only focus on the spinal cord. So the methodology they only use one algorithm, which is the ResNet 50, and the performance is accuracy 0.94 with 88% sensitivity and 89% specificity. And the journal number 2, second journal, is deep learning based high accuracy detection for lumbar and cervical degenerative disease on T2 weighted MR image. So for this journal, they only focus on the T2 weighted MRI. However, in order to detect uh, other condition like neural foraminal narrowing, we need to use T1. So for this journal, they only focus on T2 weighted MRI images of lumbar and cervical spine region collected from 308 patients, including cases of degenerative disease, spinal stenosis, and healthy control. Okay, so then the AI method that they use for this project is 3D ResNet 18. Okay, the previous one is ResNet 50. So for these authors, they use the 3D ResNet 18 architecture. So the accuracy that they obtain is 94%, sensitivity is 92%, specificity is 95%. Okay, which is quite better than the first one. But of course, they use different images, okay, different data sets, so we cannot compare. And then, okay, so these are the rest of the journals. So they use a different deep learning model. Okay, for example, the convolutional neural network, and then the VGG16. Okay, some of them use the ResNet 50 and also the white ResNet 20. So I think this is the latest one which give promising results. Okay. And the most close journal related to us is the journal number 10, the lumbar spine degenerative classification using YOLO V8 and DeepScore-Net. So they also use the same data set as ours. Okay, they use the MRI scan from the RSNA 2024 lumbar spine degenerative classification. So they use a technique AI technique, which is the YOLO V8 for detection and DeepScore-Net for classification. And they obtain the accuracy of 81% for neural foraminal narrowing, 89% for spinal canal stenosis, and 74% for subarticular stenosis. So since they use the same dataset of the MRI image as ours, okay, the same dataset. So this is our benchmark reference so that we can compare okay their method and also our method. So from the literature review, okay, this is the research gap. We found that the references are quite limited. The few studies explore comprehensive MRI-based detection for degenerative spine condition. Only few studies, but the study use different image data set. So the references or resources are quite limited. And then there is no automated system. Okay, they only use deep learning to classify, but there is no prototype or system, automated system that can automatically diagnose the low back pain. So there is a need for reliable deep learning models to automate diagnosis across the varied dataset. And they also lack of user-friendly tools for visualizing and interpreting MRI result effectively. So there is no, until now, there is no like web interface that can automatically detect and classify the severity of the degenerative spine. Okay, so for the methodology, so this is our flow chart. Okay, first we start with the data acquisition. Okay, we use the RSNA data set, and then we implement the EDA and data visualization technique to explore and understand more about the data. And then we implement the image pre-processing. Okay, like normalization, cropping, and all that. So before we can fit into the deep learning model. And then for the deep learning model, okay, we use the YOLO V8 for the object detection, okay. And then for the severity classification, we use the DeepScore-Net and ResNet 2810. Okay, and then after that, we compare and evaluate the models, and we choose the best model to implement it in the GUI. Okay, and then we develop the web interface to automatically detect and classify the severity of the degenerative spine. So these three objectives. Objective 1 is to implement the EDA and data visualization technique. Objective 2 is to implement the deep learning model, okay, to detect and diagnose the low back pain. And objective 3 is to implement the GUI, okay, to automatically detect and diagnose the low back pain. Okay, objective 1 is the data description and EDA. So for the data acquisition, the main source is the RSNA 2024 lumbar spine dataset. This one we can get from the Kaggle website. The total images are 147,000. Okay, MRI scan. So this require a lot of images and require a lot of computational tools, computational power to classify the severity. The types of MRI sequence is sagittal T1, sagittal T2 STR, and axial T2. So we use this modality, different MRI modality, okay, to detect the spine condition. So there are 3 spine condition: a neural foraminal narrowing, subarticular stenosis, and also the spinal canal stenosis. and severity, there are three classes: normal or mild, moderate, and severe. So normal means just normal, so or mild. So the low back pain is not serious yet. Moderate and severity need to have attention from the doctors or radiologists, where if the patient diagnosed with this moderate and severe, that means the patient need to undergo further treatment, okay, such as drugs or surgery. So objective 2 is to implement deep learning algorithms. Before we can implement deep learning algorithm, we need to do the image preprocessing technique. First, to convert from DICOM to PNG, because for the MRI, the images are the DICOM format. So in order to implement the deep learning model, we need to convert to PNG first. Okay, so this one you can use Python PyDICOM. Okay, the code. And then it can automatically convert from DICOM to PNG. And then number 2 is data condition splitting, because for the data set, it only put all three conditions. So we need to split into three conditions. So we have to make a 3 folder: neuroforaminal narrowing, subarticular stenosis, and spinal canal stenosis. So there are 3 conditions. And then we need to do the region of interest cropping, crop, the ROI. Okay, and then for data augmentation, because we need to add more data, okay, so in order to implement the deep learning technique. So for the deep learning algorithms, okay, first we have 3 conditions: neuroforaminal narrowing, subarticular stenosis, and spinal canal stenosis. So for the object detection, we use YOLO V8, and for the severity classification, we use the deep score net and also wide ResNet. So for this project, we only implement 2 and then we compare. Okay, maybe in future work we can explore more algorithms to diagnose this low back pain. So for severity, there are 3 classes, which is normal or mild, and then moderate, and also severe. So there are 3 classes. So the performance evaluation, okay, so we use the confusion matrix, okay, so which is predicted class and true class. I think maybe some of you are familiar with this confusion matrix. So predicted class mean, true class mean the original data, the original label or output, and predicted means after we implement the deep learning, so the deep learning, this is the result of deep learning predicted class. So for the true positive mean, the predicted class is same as the actual class. Okay, so we call it as true positive or TP. Okay, while for true negative means the predicted is negative, same as the true class, which is also negative. So for this project, for our case, the true positive means severe. So this is severe, and this one is false positive mean moderate or normal. Okay, and false positive is when the predicted is positive, but it's actually false. So the true is it is negative. Okay, false negative means it is predicted as negative and it is false. The actual one is positive. Okay, so this is confusion matrix. So from this confusion matrix, okay, we can calculate the accuracy, where TP plus TN divide by TP plus TN plus FP plus FN. So that means the true predicted, okay, and true predicted as positive and negative, plus, okay, divide by all classes. Okay, this is how we calculate the accuracy. For the precision is true positive divide by true positive plus false positive. That means predicted as positive, okay, we divide, okay, with all positive. And then for the recall, true positive divide by true positive plus false negative, this area. Okay, and F1 score is 2 time precision time recall, divide by precision plus recall. So this is how we calculate the F1 score. So the F1 score consider both precision and recall. So we cannot rely on just accuracy, because accuracy means only true when the class are predicted correctly, only correct prediction. But we do not consider the false prediction. So precision and recall can overcome this issue. So they also consider the misdiagnose. Okay, means when the classes are predicted wrongly. So that's why we need to consider all of these evaluation metrics. So the GUI, okay, we use the Flask, okay, Python. Flask is a Python library for GUI development. So why we use Flask? Okay, it is a custom interface. It can build the flexible HTML and CSS interfaces. And number two, it can support image upload and result display. And number three, it is a Python backend, connect directly to the deep learning model. So Flask is quite useful when we developing the GUI. Results and discussion. So from this experiment, okay, for the objective one, data description and EDA, okay, so we found that for three condition, foraminal subarticular and canal stenosis. So we can visualize the images. Okay, we can we can visualize the data. So for this condition, foraminal condition, so these are the distribution data. Okay, where the blue color show the normal or mild, and the orange color show the moderate, and green color show the severity, the severe class. So that means the majority of the class are in this region lah, normal and mild. Okay, using all the view of the MRI. So this is the MRI image. Okay, and then for the condition, subarticular condition, so the blue color show the normal, okay, and the orange color show the moderate, and green color show the severe. That means majority of the classes are normal. So it is show that the data are not balanced, because most of the data are normal and only few are severe. And for the canal condition, the blue is moderate. Okay, okay. So orange color show the normal or mild, okay, and blue color show the moderate, and the green color show the severe. So that means the majority of the classes are also normal and mild, okay, while moderate and severe are quite less, especially for the severe class. Okay, so number of files for each modality. Okay, we use three modality, okay, for axial T2, sagittal T1, and sagittal T2, because each of the modality can detect the different condition of the degenerative spine. Okay, so for the axial T2, sum of number of images, total images 79. Okay, sagittal T1 is 33,670, and sagittal T2 is 33,569. So total of the images are 147 and 218. And number of series, this one. And average file per case is like this. Okay, minimum is 5 and maximum is 192, which is consists of this 79. So most of the images are comes from the axial T2. Okay, and the rest are sagittal T1 and sagittal T2. Okay, so this is the example of images of axial T2. Axial means this side. Okay, so this one is sagittal T2, the back one, and this one is sagittal T1. Okay, now we want to implement the deep learning algorithms. Okay, so these are the results. First, we need to do image pre-processing. We need to convert from DICOM to PNG. Okay, because of MRI image in DICOM format. So it is difficult to implement in deep learning. So we need to convert to PNG format in order to implement the deep learning model. So these are the example of the MRI image after conversion. Okay, the first example is the condition of subarticular stenosis. This one is spinal canal stenosis, and this one is neural foraminal narrowing. Okay, so and then number 2, next we need to do the data condition splitting. So we need to differentiate or divide, okay, splitting the images according to its condition. So we have 3 conditions: neural foraminal narrowing, and then spinal canal stenosis and subarticular stenosis. Okay, and then we need to do the cropping, okay, according to the region of interest. So this subarticular stenosis, so this is the ROI, and then spinal canal stenosis, and then this one is the neural foraminal narrowing. And then for the data augmentation, okay, next we need to add more images. So before augmentation like this, and then the technique we use for augmentation is the noise injection. So we inject the noise, so we get more images. This one is before augmentation. This one we rotate the image, okay, then we get more data like this. So these are the total number of images before augmentation and after augmentation. So original images for this condition is 15,751. After we do augmented images is about 2,574. So total is 18. Okay. So subarticular stenosis also we add more 2,851, and total images is 18,223. And for the spinal canal stenosis, the augmented images is 957, and the total images for this condition 8,760. So total images is 45,308. So for the data training and validation, we use the 5-cross validation. What does it mean? It means that the data set has been split into 5 equal fold. So 5-fold means 4-fold used for training and 1-fold used for validation. So that means 5-fold mean divided by 5, okay, 5 set. So 4/5 used for training. That means 80% for training and 20% for validation. So why we use the 5-fold cross validation? Because it is a balanced evaluation. It can reduce overfitting and also efficient use of data. So that means there is no balance. So we use all the data for training and validation or testing. Okay, so these are the results for model training. Okay, so the first condition is the neural foraminal narrowing. So first we implement the deep score net. Okay, so this is the training and validation loss of neural foraminal narrowing using deep score net. So you can see this is fold 1, okay, fold 0 to fold 0, 1, 2, 3, 4. So it means 5-fold cross validation. So you can see the loss, okay, for training is going down, but for the validation is quite not it's not stable lah. Okay, so but after fold 1, fold 2, fold 3, fold 4, the loss is quite improved lah compared to the first one. And then this right graph show the training and validation accuracy of neural foraminal narrowing using deep score net. So as you can see, first this is the epoch. The first one is 70%, but after certain epoch, it can increase to around 90 something for the fold 0, and then fold 1, 2, 3, and 4. So the training set, okay, the accuracy is increasing. Okay, but for the validation set, it's not so stable like this. So overall, for this condition, the neuroforaminal narrowing, the full one give the best accuracy, where the accuracy is 0.805, precision is 0.830, recall is 0.805, and the F1 score is 0.815. So compared to other fold, so fold 1 give the highest accuracy. Okay, and the lowest accuracy is fold 4. Okay. And then we also implement the white ResNet 2810. Okay, previously we used deep score net. Okay, we get this result. And when we use the white ResNet 2810, so this is the training and validation loss of neuroforaminal narrowing using white ResNet. So you can see the loss, okay, decrease, okay, and the accuracy increase from 70 something to 90 something, which is quite good. Okay, so this is the table shows the summary of the accuracy and also precision, recall, and F1 score. So the full one show the highest accuracy around 0.846, precision is 0.832, recall is 0.846, and F1 score is 0.835. So this shows that the white ResNet give better accuracy compared to the previous one, compared to deep score net for this condition. Okay, and then we also implement for two condition, the other two condition, which is the spinal canal stenosis. Okay, so these are the training and validation loss of spinal canal stenosis using the deep score net, and this is the training and validation accuracy. Okay, where we can see the training has been increased over the epoch. So for this condition, spinal canal stenosis condition, the full zero give accuracy 0.904, which is the highest. Precision is 0.911, recall 0.904, and F1 score is 0.907. Okay, and we also compare with white ResNet 2810. So this is the training and validation loss, and this is the training and validation accuracy. So for the accuracy, full tree give the highest result, 0.913 accuracy, precision is 0.909, okay, then recall is 0.913, and F1 score is 0.910. Okay, so this is white ResNet 2810. So compared to the deep score net, obviously the white ResNet give better accuracy. Then we also implement for condition number 3, the subarticular stenosis. Okay. Sorry. Okay. So for the condition number 3, the subarticular stenosis, we also use the deep score net. And also this is the accuracy. So for the deep score net, it give full one give the highest accuracy, 0.806, precision is 0.812, recall 0.806, and F1 score is 0.809. Okay, when we compare with white ResNet 2810, okay, so this is the training and validation loss and also training and validation accuracy. So white ResNet give better accuracy. Okay. For one, give the highest accuracy 0.820, precision 0.808, recall 0.820, and F1 score is 0.812. So the lowest is fold 2. Okay. However, we can say that the white ResNet 2810 give a better accuracy compared to the deep score net. Okay, so this is the confusion matrix. Okay, so for neuroforaminal narrowing, so this is the normal class. So these are the moderate and severe. So this is the true positive. Okay, for normal mild. So 86. So this is false positive. Okay. So because this is not binary classification, this is multi-classification because we use 3 classes: normal, mild, moderate, and severe. So that's why we have 3 by 3 lah. Okay, so this is false positive, this is false true positive, and this is false negative. So this is the classification report. So overall, normal mild is 0.93, moderate 0.48, severe 0.51. So this is the recall and F1 score. Okay, and we also do the same thing for the white ResNet 2810 for condition number 1, neuroforaminal narrowing. So this is the result for spinal canal stenosis. So the accuracy is quite okay, high, 97%. And for white ResNet, the severe is 0.71. Okay, compared to deep score net, it just gives 0.57. So that means the white ResNet 28 can classify better compared to the deep score net. And then for the condition number 3, the subarticular stenosis. So these are the results: deep score net and white ResNet. Okay. I think we can understand better when we look at the table. Okay, for foraminal narrowing, okay, deep score net give accuracy 0.805, while the white ResNet 28 give the accuracy 0.846. Okay, for spinal canal stenosis, the white ResNet 28 gives 0.913 compared to the deep score net 0.904, and subarticular stenosis, deep score net gives 0.806, while the white ResNet gives 0.82. So all compared to all condition, we can say that white ResNet 2810 achieved the highest accuracy across all the condition. That means neuroforaminal narrowing, spinal canal stenosis, and also subarticular stenosis. So comparison with previous work, okay, we also compare with this benchmark journal results. So for this paper, it also used the same image, same data set with us, and they also use YOLO V8 for detection and deep score net for classification. So they obtain 81% for neuroforamining. Okay, and for spinal canal stenosis, they obtain 89, while for our proposed work, we get 91.3% with the white ResNet 2810. And for the subarticular stenosis, they obtain 74%, while for us, for our proposed work, we propose white ResNet 28, we obtain 0.82, I mean 82%. So our proposed work quite higher compared to them. So we can say that the white ResNet has potential to detect and diagnose the spine, okay, correctly. And then we also implement the GUI. Okay, the reason is we want a user to test. Okay, the user can upload the image and the result will automatically come out. So these are the GUI development. Okay, so it gives you the step. First, drop image, upload the JPEG, DICOM for each disease. Okay, this is for the subarticular stenosis. This is for neuroformatting, for neural narrowing, and this is for spinal canal stenosis. So there are 3 conditions. So the user can upload all the images. Okay, and then click the analyze. Okay, then the result will come out and the user can print the result and give to doctor so that the doctor can give suggest a better treatment, okay, based on these results. So these are the example. Okay, when the user upload the images, so it give the GUI can give the results. Okay, so for example, for these images, it give the severe and moderate finding detected. So it detect the severe and moderate condition. So it suggests to see a spine specialist at the earliest convenient. Okay, if the result is severe and moderate, that means it's quite critical. So the user need to go to the doctor or specialist to further treatment or further diagnosis. Okay, so this is the example of Segel 31. Okay, so the user, when the user upload the images, so these are the results. Okay, detected severe and moderate. So the result also give detail location, where is the moderate, where is normal, and so on. Okay, same with the Segel 32 for the spinal canal stenosis. Okay, so the result also display for all location L1, L2. So whether it's normal. So for L1, L2 normal, but L2, L3 is moderate, and L3, L4 is severe moderate. So like this. So the GUI can give exact location. Okay, and also give the classification, the class, whether it's normal, whether it's moderate, or whether it's severe. So the conclusion is, okay, we already implement the effective pre-processing technique, which is DICOM to PNG conversion, data splitting, ROI, the region of interest cropping, and also the balance augmentation. So we also implement the deep learning models, the YOLO V8 for detection, and deep ScoreNet and wide ResNet for classification. And we implement the 5-fold cross-validation. And the results show that the wide ResNet 2810 achieved the highest accuracy compared to the deep ScoreNet, okay, across all the 3 conditions. However, our limitation is our data is not balanced. Okay, the majority cases are normal and mild. However, the few sample are for moderate and severe cases. And also because the image are too large, okay, and limited GPU slow down the training. So if you have powerful GPU, it can increase the performance of the training. So future work, we would like to do the model optimization to improve accuracy with lower processing costs. Maybe we need to use tuning, pruning, or lightweight models. And GUI enhancement, okay, we can improve the GUI. So this is the first stage of our project. So we can improve more with auto detect the MRI sequence like Azian T2, Segel 31, and etc. So we can automatically select the model based on the sequence. Then number 3, expect the impact to have a smarter, faster, and more reliable diagnostic, improve user experience, and clinical usability. Okay, so these are the references. And if you have further question, you can contact me at this email address.
Okay, any question answer? Thank you, ma'am.
Okay.
Any questions from participant?
Any questions?
Yes, unmute yourself and ask. Yes. Yes, Diraj. Yeah.
Yes, ma'am.
Yes, Diraj. Yes.
And the accuracy, precision, and all that you have showed us, are they test accuracy or the training accuracy?
This one is validation accuracy. The final one, right?
Yeah. Yes, ma'am.
The final one is validation accuracy.
Okay. Okay, ma'am. Okay.
The first one, okay. Sorry, when I show you this, this is a model training. This is training accuracy, and then the next one, this one is testing accuracy.
Okay, ma'am.
Uh,
Ma'am. Okay, ma'am. Okay.
okay. Actually, I want to show you how you can download the data. So wait, stop sharing.
Yatharth, any question from your side?
Okay. Wait.
Okay. So we just
Share.
show the download.
Yeah, maybe I can show the data source, huh? Okay, so you can go to this Kaggle. Okay, can you see the website?
Yes, yes.
Okay, this. Okay, how many of you are familiar with Kaggle? Oh, this is your first time see Kaggle.
I think almost all familiar.
Yeah, familiar. So this RSNA, okay, 2024 Lumbar Spine Degenerative Classification. So the RSNA stand for Radiological Society of North America. So they host competition to do this automated classification. Not automated, is to do for this detection and classification. So the prizes is $50,000 US dollar. So the competition is already closed last year, October 9. So these are the overview, and this is the data. Okay, but you need to sign in, okay, in order to download the data, because the data is quite large, around 35 gigabyte. So the type of the data is DICOM and CSV file. Okay, so the files content of training and testing. So first, the CSV give you the image, number, and condition, such as spinal or spinal canal stenosis, and severity level, such example, normal, moderate, or severe. Okay, so you can download download the data, so you can get all the images. Okay, so these are the test images and the train images. So you can download this, and then you can go to code. This is the example of code they already provided, and we can try to open. Okay, so this one of the the goal, I think, number one prize. So they discuss, okay, they upload the code, and this one can be as good reference for you, because it give detailed explanation about the location, about the lumbar spine, normal, severity. So you can see normal like this, mild like this. So you can see the difference between normal and severe. So you can do self-study. And the good thing is you can uh, edit. You can copy the code like this. Okay, so you don't have to, before you can put in Jupyter or Google Colab, you also can simulate the coding in this Kaggle notebook. So you can go to the code like this. So this is the explanation. Okay, so these are the code. So we can click here, and then we can run. Okay, we can run like this. So you can see the coding here, and then you can learn. Before you can implement your own deep learning model. So these are the example of how you can do self-study. Okay, so you can copy the code and then run. Copy the code and run. So total cases is 1,975. Okay, then you can load the images. So these are the code for load image. Okay, then you can read the CSV file. So these are the coding for data loading. Okay, then you can print this one. Of course, we need to run from the beginning lah. We can simulate, we can do the coding from the top until down. Okay, so this is how you can do to learn. So actually there are a lot of example of the coding that has been developed by others that you can try. Like this, I think this one can be used. You can explore more lah. So I think it's quite good to study. Okay? Any questions?
Yeah, I think all of you, yes, Abhishek, all of you just go through the materials which ma'am is sharing. If any doubt, you can contact to ma'am directly. There's mail ID is given. Yes, Ayush and Abhishek. Ayush first. Ayush.
Yes.
Just want to ask that since I'm an engineering student, so can I refer this notebook section for study purpose? I mean, as a for learning.
Yes, can. Because
Yeah,
this one is open source. This one you can go to kaggle.com and then but you have to log in order to download the data. You need to log in first. So you can go to this and go to like this. There are a lot of data set. If you're interested, right? So there are a lot of interested. There are a lot of data set uploaded in this notebook. Okay, for competition, this competition like this. So you can go to the data set and then you can download the data and you can go to the code or models like this. So you can, for example, this one, EfficientNet. Okay, I use DeepScoreNet and WireNet, but the others also implement the EfficientNet v2. So you can try to look at their code and try to uh, copy and code lah, copy and edit like this. So you can copy and edit and try in this notebook. Before you can start with your Python in Jupyter or Google Colab, you can also try first using this Kaggle notebook. So these are the yeah.
I have one more question from the five-fold cross validation. I just want to ask that since we are dividing the data set into 5, right? The fifth one we are using for testing purpose. And then we are left over with four folds. That is 0, 1, 2, 3, 4. I mean 0, 1, 2, 3. Yeah. So I just want to ask you, what is the significance of like having these 4 folds and then finding that which fold is giving more accuracy, as all the 4 folds we are using for training purpose only.
Okay. That's good question. Actually, we use five-fold cross validation. Actually, wait, okay, like this. Okay, so the purpose, why? Because fold 0, we just use we want to show the accuracy of each fold. However, for the overall accuracy, we need to average all fold 0, 1, 2, 3, 4. This is to show each of the fold 1, fold 2 like accuracy, but actually the valid results we need to show the average of all fold.
Thank you.
Yeah.
Hello, ma'am.
Yeah. Okay.
Ma'am, in case of bones, bone density also plays a very crucial role, right? So do the model analyze the bone density for these cases, or it is possible, or just it detect the shape of the images or something?
Okay, our project just show just detect whether it's severe, normal, or mild, moderate. Okay, and also show the location like this. Okay, but we don't implement yet the bone density. So maybe future work we can implement this.
Okay, ma'am.
Am I answering your question?
Yeah, ma'am, sure, ma'am. With that.
Yeah. So it just classify the severity like normal, moderate, but we do not consider yet the bone density. So because bone density, we need to use other parameter. I think I'm not sure the imaging can give the density. Maybe can calculate lah, but for currently only this detection and location.
Okay.
Okay.
Thank you, ma'am.
Any
Ma'am,
other
once,
questions?
ma'am, once can you please elaborate the Kaggle competition section? I mean, how they compete and on what? Like, as the site is also new for me.
Okay. For this, the Kaggle is a platform for the machine learning scientists, okay, all over the world, can participate. That means, some of the institution like this, the society, they want the result. Okay, they have the data, but they don't know they do not have the solution. So they host the competition. That means they give the data set. Okay, they give the data set and then they invite all the machine learning engineers or data scientists all over the world to participate. So they can log in, okay, and then they can download the images, okay, and then they can submit the competition. So because this one, the host want they want, this is the result, they want submission are evaluated using the average or sample weighted log losses. So these are the result that they want. So the machine learning engineers can propose deep learning algorithm or other machine learning algorithm to get what they want. Like this one, they want the weight, okay, or probability. So these are the example of the results. So they can submit. Okay, so this is the leaderboard. Okay, so the team, okay, for example, the team Avengers get the score for the weighted average 0.388, while others are quite higher. So the lowest probability means it can predict accurately. So they won the first prize lah, the gold. So this the results. Okay, these are the members. Okay, the score 0.338 and they won the first prize. Okay, entry, they can put many entry. So these are the solutions. So you can see the solution also. Okay, and then you can use it for your self-study, how to do machine learning, okay, how to do the algorithm and all that, image pre-processing. They show all the detail lah. So if you expert in machine learning, you also can take part, can join this competition. I think it's good platform for machine learning.
And in return, what these companies, I mean, they give to the participants, I mean,
The
do they?
price?
Yeah, and the price, I mean,
The price different according to the host. So this host give 50,000 USD, which is quite large, right? It's a big amount of money. So for the first prize, if there are a lot of entrants and participant, so there are 2,400. So they need to compete to get the first prize. I mean the lowest score. So this person won 50,000 US dollar. Okay. So there are a lot of competition. So you can try to look at, for example, this one, 2 million. 2 million. Okay. So the prize and award is 2 million. Okay. And then until now, there are 1,000 participants, but the timeline is, I think, 4 months to go. So still ongoing. So you can join lah. But you have to expert first. So there are a lot of competition. If you expert in machine learning, you can participate. So you can get the prize here. 50,000 USD, 100,000 USD. Okay, I think it's good. Even
okay.
Even though the competition is over, you also can download that data and try on your own lah, for your own knowledge and skills, machine learning skills.
Okay, thank you, ma'am, for
Okay,
clarifying my doubts.
all right.
Any other questions? Is Abhishek, you want to ask anything or we'll stop?
Ma'am, in your AI model, you use the PNG format, right? Because of YOLO 8. So in other models like Monet, we use the Nifty format, right? So will it give better accuracy than this, using the 3D models?
I haven't test yet. For current being, we only use PNG because original MRI image is DICOM. Okay, so we just convert to PNG. But if you use other format, maybe you can try.
Okay.
You can try, but I think PNG is the most simplest.
Yeah.
Mm.
Okay, ma'am. Thank you.
Okay.
Okay, any other questions? Ma'am, if any of the students want to pursue his MS in your university or PhD, so what is the procedure?
The procedure, you need to contact supervisor, the potential supervisor. If you want to do master or PhD under me, you can email me and I can give you some project, and then you need to submit a proposal to our Center of Graduate Studies department. So okay, they will have a meeting, and then they if accepted, then the program will start.
Okay, then this is for your side students, if anyone interested. But before that, ma'am will give the project, you have to complete that one. Then only we'll think for the next time, otherwise.
Okay, so I also planning to apply some grants. So if we have grant, so we can also give you allowance, monthly allowance, okay, for you to study here. So maybe you can stay in India, okay, but during a proposal defense or final defense, you need to come to Malaysia.
Yes, very good.
Maybe we can do some distance lah.
Now, combiningly, we'll think to apply some projects. Okay, after this winter school, we'll think for discuss for that.
Okay.
Thank you very much, ma'am. In busy schedule in this New Year time also, you have accepted our request.
Can we take photos together?
Yes, all of you, anyone free, you just on your video so that we can take the photo. I will share this video to you also.
Okay.
Okay, this is recording. So all of you, just anyone, if you wants to take the photo, you just on your video so that you can take one snap. Abhishek, Ayush, Dheeraj, anyone in the mode of taking photo, you can on your video. Yes, no one.
No one.
No one. Everyone is at home, man. That's why. Anyhow,
It is disabled. So.
The video is disabled.
Okay, sorry. Just a minute. Yes, now you can on your video. Yeah. Sorry. Very sorry from my side. Yeah.
Okay, nice to see all of you.
Okay.
So the student and engineering student or medical student?
Maximum 95% engineering students are there. All are BTech students from our university, from other university also.
Okay.
Okay. Thank you very much, ma'am. I will contact you soon. Thank you.
Thank you for your time. And if you have time, if you have question, you can email me later.
Thank you, definitely, ma'am. Thank you.
Okay.
Thank you very much. Bye.
Thank you. Okay, see you again. Bye.
Bye.